Hi dear students, how are you? In this session we are going to talk and discuss valence, stability of inert gas atoms, or we can say that they are noble gases. In nature, only inert gas atoms such as helium, neon, argon have a certain chemical properties. These are monoatomic gases stable under ordinary temperature and pressure conditions. This feature is related to the electronic configuration of the outer layer of a noble gas atoms. First of all, noble gases or inert gases are located here in the periodic table in column 18 or group 8. As you see here, helium, neon, and argon. And in order to make their electronic configuration, first of all we must have the atomic number. And then from atomic number we can deduce the number of protons, and we can also determine the number of electrons. Since atom is a neutral, the number of protons equal to the number of electrons equal to atomic number. So here, helium has 2 electrons. So the electronic configuration is just K2. It has just one energy level, and this energy level is saturated with 2 electrons. K cannot contain more than 2 electrons. It is saturated by 2 electrons. Neon here has 10 electrons. So the electronic configuration is K2 remains 8, so L8, and then neon has 2 energy levels and its valence shell is L, and this valence shell is saturated with 8 electrons. L cannot contain more than 8 electrons. And now argon. Argon has 18 electrons. So the electronic configuration for it is K2, L8, 2 plus 8, 10 remains 8, so M8. And M here is the last energy level, and it is the valence shell or outer shell, and contain here 8 electrons, and M here is saturated since M cannot contain more than 8 electrons. So here we can deduce that the outer shell for these 3 atoms is saturated. Helium is saturated with 2 electrons, whereas neon and argon saturated with 8 electrons. Now, as a conclusion, the atoms of noble gases are stable because they possess on the outer shell either 2 electrons or a duet of electrons, for example helium, either 8 electrons or octet of electrons for other noble gases such as neon and argon. Duet and octet rule. Duet rule. Atoms whose atomic number is closer to that of helium, they tend to adopt or achieve its stable 2 electron configuration or achieve its duet rule to be as helium K2. Whereas octet rule, other atoms tend to adopt the external electronic configuration with 8 electrons to be saturated like that of noble gases, argon and neon, and the valence shell here saturated with 8 electrons, and we can say they achieve its octet rule or their octet rule. Now monoatomic ions. Atoms can lose or gain 1 or more electrons to obey or achieve its octet or duet rule. An atom that has lost 1 or more electron becomes a positive monoatomic ion, and it is called cations. Whereas the atoms that gain 1 or more electrons becomes negative monoatomic ion and called anion. You know that atom is a neutral, but not all of them are saturated. Just those that belong to column 18 or group 8 are saturated, but The others are not saturated. Monoatomic cations that are positively charged. First of all, here we have a sodium atom that has 11 electrons. The electronic configuration for sodium atom is K2L8M1 2 plus 8 10 plus 1 11. So here, if we look to the last energy level, or to the valence shell, or to the outer shell, we can note here that M contains just one electron, which means that M is not saturated. In order to be saturated, this atom, which is sodium, that has one valence electron, tends to lose one electron to achieve its octet rule and become a sodium ion with electron configuration K2L8. And now, to determine the ion charge or the charge of this ion or the symbol of this ion, it will be Na+. And now, magnesium here has 12 electrons, and the electronic configuration for it is K2L8M2. The valence shell here is M. The outer shell here is M. The valence electrons here is 2, which means that M is not saturated with 8 electrons, and M has just 2 electrons. So, in order to be saturated or to achieve its octet rule, this atom, which is magnesium, tends to lose 2 electrons to be a magnesium ion of electronic configuration K2L8, and its ion or the charge is Mg2+, the symbol of it. And now, aluminium that has 13 electrons. Its electronic configuration is K2L8M3. Also here, M is not saturated. M here is the valence shell. M here is the outer shell. M here is the last energy level. M here has 3 electrons, or the valence electrons is equal to 3, which means it's not saturated. And then in order to be saturated, aluminium atom tends to lose these 3 electrons to become saturated of electron configuration K2 and L8, and then it turns to be a aluminium ion Al3+. Now calcium. Calcium has 20 electrons. The electronic configuration of it is K2, L8, M8, and 2, 2 plus 8, 10, plus 8, 18, plus 2, 20. So here, the last energy level is N. The valence shell is N. The outer shell is N. N has 2 electrons. N here is not saturated. N can contain 8 electrons, but here it contains 2 electrons. So here, calcium atom tends to lose 2 electrons to become a stable ion, to become Ca2+ of electronic configuration K2L8M8. So here, as a conclusion, I can say sodium has a tendency to lose 1 electron to be sodium ion Na+, to achieve its octet rule, to become as neon atom. Magnesium here has a tendency also to lose 2 electrons here, to become a magnesium ion Mg2+, to achieve its octet rule, to become as neon atom. Aluminium here tends to lose 3 electrons to become aluminium ion Al3+, to be as saturated as also neon atom. Calcium here has a tendency to lose 2 electrons to become stable, to achieve its octet rule, to be calcium ion Ca2+, and then its electronic configuration is as argon. Now monoatomic anions that are negatively charged Here we have a fluorine. The first atom here is a fluorine that has 9 electrons. Its electronic configuration is K2S7. L here is the valence shell or the outer shell, or also we can say that it is the outer energy level or last energy level. L here is not saturated. L here contains just 7 electrons and it can contain 8 electrons. So fluorine atom, in order to be saturated, it will gain 1 electron to achieve its octet rule, to become K2L8, to become stable and to be a fluoride ion. And now chlorine here contains 17 electrons. Its electron configuration is K2L8 M7, 2 plus 8 10 plus 7 17. The valence shell here is M here contains 7 electrons, which means M here is not saturated, and to be saturated it must gain 1 electron to be K2L8 L8 M8. Look here, M7 plus 1 will be M8, so it gains 1 electron to be stable, to be chloride ion. Okay, oxygen here has 8 electrons, so electron configuration of it is K2S6. The last energy level here is L. L contains 6 electrons. The valence electrons here equal to 6, which means L here is not saturated, and in order to be saturated, to be 8 electrons, it must gain 2 electrons, and then to be stable, K2L8, and then it will become an ion which is called oxide ion. Now, nitrogen. Nitrogen has 7 electrons. Its electronic configuration is K2L5. L here also is not saturated. It contains just 5 electrons. And in order to be saturated, it must gain 3 electrons. Look here, if we add 3 to 5, it will be 8. So K2L8, now it will be stable, and then it will turn to be nitride ion. And then sulfur here contains 16 electrons. Its electronic configuration is K2L8M6, 2 plus 8 10 plus 6 16. M here also is not saturated, does not contain 8 electrons. So the valence electron here, if we look to it, is 6 electron. Then to be saturated, to achieve its octet rule, to become or to have 8 electrons, it must gain 2 electrons, and then M will be 8 electron. And in this case, the sulfur that tends to gain 2 electrons becomes stable ion, sulfide ion of electronic configuration K2L8 and M8. So here as a conclusion, we can say that when the number or the valence electron is greater than 4, in this case, look here, 5, 6, and 7, these will tend to gain electrons, not to lose. Tend to gain electrons to achieve their octet rule. Octet rule means to be saturated with 8 electrons. Now we look to the number of electrons at the last energy level, or to the valence electrons. You know that the number of electrons at the last energy level means valence electrons, and the last energy level is the valence shell. If we note that the valence electron is greater than 4, so now we add electrons, or this atom gains electrons in order to become stable, to have 8 electrons at the last energy level. 7 to be 8 just need 1, so it will gain 1 electron. 6 to be 8, it must gain 2 electrons. And 5 also to be 8, it must gain 3 electrons. And now be careful here that the name of the anions will be different than the name of their atoms. Fluorine will be fluoride. So when I tell you that fluoride ion, fluoride, you must know that it is a case of form of ion, not atom. Also chloride, IDE. Oxide nitride, and sulfide. You know them from grade 8, just to remember them.